how the beast was made, A Tale of Pacific Northwest Red Raspberry Fields. So this is actually a study on resistance, and it began back in 2017. And back then we had some real strong activity with spider mites, and real problems up here in Whatcom County and red raspberry and even in blueberry. So we decided in 2017 to come up and do a little preliminary study, and we looked at two different products. We looked at acromite, which is bifenazate, and we also looked at brigade, which is your bifenthrin. Brigade is one of the few products that is registered and labeled as an insecticide miticide, and it's one that's often used as a cleanup spray. So we knew that the mites would be subjected to this. And so we looked at these two products, and you can see what happened. Primarily, it was just to prove to the growers that, yes, there was something that would control the mites, and acromite controlled them really well. You can see that even at the quarter rate, it did really well. Unfortunately, brigade is another matter. Bifenthrin is something that these mites have seen year after year. And as you can see, the level has certainly dropped. Percent mortality was really low, not much different than your control, or even worse than control in some places. So why is it that spider mites are so prone to resistance? There are a couple of, or three things actually. They have a very short life cycle. They lay a lot of eggs, and they have a type of reproduction called aeronautic. And that means when the female lays unfertilized eggs, they turn to males. And if the female lays fertilized eggs, then there'll be females. So these three things promote the possibility of resistance. So based on the arthropod pesticide resistance database as of today, two-spotted spider mites are actually the winners. They're the most resistant arthropod in the world. And there's about 512 different cases of resistance reported. And look at this list. So the first one is Agramec. This is abamectin. And there's been about 53 different cases reported. Acromite, bifenazate, only 14. Savvy, 11. Vindex and malathion both have about 7. Bifenthrin, 5. Canamite, which is acequinacil, that one has about 4 reports, and Zeal and Danitol both have 3. So it's resistant to a lot of different things, and it has the potential to develop resistance. So it's something we have to keep our eyes on. So in 2018, we received funding from the Red Raspberry Commission and the State Commission on Pesticide Registration to continue our testing, looking at tolerance levels, building in fields, perhaps even resistance. So we started out with 4 different treatments. We looked at acromite, we looked at banter, we looked at agramec, and we looked at brigade. And if you look at the first 2 of those, you notice that they both have the same active ingredient. So at that time, they were owned by 2 different companies, and there was a request that we look at both of these. And so we normally don't look at the same active ingredient across different products, but in this case we did. We looked at 2 different locations. So there were 2 different growers, but there were 3 different fields. And in one of those fields, there was Wakefield. The other 2 were Meeker. And the way we gathered the mites was we just collected the leaves. So these were field-aged or field-collected females, and they were mixed-aged females that we tested. We wanted it to be just like it would be in the field if you were to make an application of these products. So in this slide, what I want you to see is I want you to look at the parts per million, and I want you to look at the number of mites that we used. So in a test like this, how you put it together is, so you bring those females back, you're taking a little artist brush and you're moving each female over to one of those leaf discs. And so imagine, you're doing this over 4,000 times. So it was quite an involved study, and we did this, we repeated it 3 times. And you can see we use a Potter spray tower, which is the standard method for doing these types of studies. And you can look at the field rates. We use the high field rate, we use the half field rate, we use the quarter field rate. And those are the mites we used, and this is how we calculated it. The efficacy of the acaricide was equal to the total dead spider mites over the total spider mites in the Petri dish times 100. So the results were pretty interesting. So I need you to separate this table into 2 parts, actually. So on the right side, you'll see the LC50 and percent dead mites over there. And then on the rest of it, you're looking at the field rate and the quarter field rate. So if you look at the field rate, acromite had about 80% mortality, and this is after 24 hours. So we're not looking at residual, long-term residual studies in the field. This is simply looking and comparing these across 24 hours. So in this case, at the full label rate, we had about 80% dead mites, 80%. And then if you look at the quarter rate, you'll see that we had about 65%. So we had a drop of about 15% when we dropped to that quarter field rate. If you look at banter, at the full field rate, we were getting around 60% mortality. And then at the quarter field rate, it drops proportionally, just like acromite did, down about 15% to 45%. Agromec, we were getting 99% mortality after 24 hours. And then with the quarter field rate after 24 hours, we were still getting 97% mortality. So agromec was pretty potent, but the other ones are fairly potent as well. And if you look at brigade, however, this is your bifenthrin. After 24 hours, we were only getting 20% mortality. And then when you drop it down to the quarter rate, you might as well forget it. This is 13% right there. Now on the right side, we're talking about LC50. And LC50 is a lethal concentration of, it's the amount of active ingredient that's required to kill 50% of that population. And it's calculated using a test called the probit analysis. And in this case, you can see that the LC50 for acromite is around 46.5 parts per million, but banter, which is the same active ingredient, however, it takes about 5 times more in order to reach that 50%. So we're not talking about a half rate, we're talking about the LC50, which is just a type of a measurement. So in this graph, you're going to see that here are your different products, and you're going to see that all of them actually performed differently from each other. In this graph, you're going to see the full dose, the half rate, and the quarter rate versus the control. And so in this case, you can see that, for example, if you look at acromite right here, this letter B is no different from the half rate here. But of course, the quarter rate, it does drop down. If you look at agromec, it's the same for the full dose, the same for the half rate, and the same for a quarter rate. If you're looking at banter, which is your blue, again, the full rate performed as well as the half rate did. And then, of course, here's your bifenthrin down here, and it did not perform very well at all. And in fact, you can see a significant difference between acromite and banter at these different rates. And frankly, bifenthrin really underperformed as a miticide. But most people don't use bifenthrin as a miticide, but certainly it's one that they use on their fields. So let's look at the probit analysis. In this case, so what you're looking for, let me see if I can show you. So in this case, you're looking for this 0.5. So we're trying to kill 50%. So if you bring this over here, you're going to drop down and see what level it is. For example, acromite is pretty low. So it takes around less than 100. I can't see on this slide, but less than 100 parts per million to kill 50% of the population. Compared to banter, although this curve seems rather similar, it takes about 5 times more. And then if you look at brigade, unfortunately, the graph isn't big enough to show you the 50% LC50 level for brigade. And in this case, we were only able to reach 20%. And agromec, you can see how very close it is to a very small amount that it takes to get that 50% of the population dead. So the mites were highly susceptible to agromec. There was a 5-fold difference between acromite and banter, and the graph wasn't big enough to reach 50% for the brigade. Now, this data set is accurate for these fields at this time. So we looked at 3 different fields. Are those populations the same all over Whatcom County? It's unlikely, because when it comes to efficacy and when it comes to how products work, it's just as much the ability or the management of the grower than it is efficacy. Another thing we have to consider is seasonality. So what's going on at this time? A lot of your miticides are put on post-harvest. And at that time, if you were to turn over leaves and look at them in the field, you would see that there's high numbers of predatory mites and other beneficials. Those are like money in the bank for you. Look at over this guy right here. This one is actually a commercially available predatory mite, and this one was found wild in the Whatcom County raspberry fields back in 2017. This is Phytocellulis persimilis. You pay money for this. This is worth a lot of money. Look down at this one. This is another native. This is Neocoelus phallacis, and this is one of the ones in your fields that are cleaning up those spider mites. So in other words, it's not all about numbers when it comes to how miticides are performing in the field. It's what else is going on too. And in this case, if we were just to knock those spider mite numbers down a little bit, all these predatory mites, all these beneficials are going to move in and they're going to clean it up. And this is what we see year after year. And this is what you will experience. Once you stop putting on those SWD sprays, those predatory mites are moving up into the leaves to take over and feed on those spider mites. So it's really a knockdown. That's all that's needed. So the conclusions are this. So in this case, for this data set, the lower field rate for the 3 miticides, and I'm not talking about bifenthrin, they acted as well as they performed as well as the full rate. Now, I'm not saying that the half rate of bifenthrin or the half rate of acromite performed as well as the half rate of agromec, but I'm saying that the half rate of the agromec performed as well as the full rate. The half rate of banter performed as well as the full rate of banter. And the half rate of your acromite performed as well as the full rate of the acromite. But this is looking at one dimension. It could be that the higher amounts are going to give you a little more residual activity. But for right now, we're only looking at efficacy or percent mortality after 24 hours. Bifenazate is known as being very soft on your predators, whereas abamectin is pretty hard on predators. So when you're making those choices and you want to rely on your predatory mites to come in and finish off those spider mites, then you might want to choose a product as one of the bifenazate products, whether it be banter or whether it be acromite, as your choice for that time of year to kind of help out your predatory mites, to knock those numbers down, but to allow those predators to move in and finish things off. In this study, we found no interactions between cultivar and the mites. So that meant that there was no difference in efficacy of these products, whether it be on the Wakefield or whether it be on the Meeker. They were about the same. But we did find interactions between the location and the mites. So this kind of suggests that the way that a person manages his field can affect the performance of his acaricides. And so what do I mean by that, actually? So actually, I mean that if you look at this field, you can see that those red raspberry plants are perennials. You're going to leave them in your field for maybe 8 years or so. And so those spider mites that are living in your field, those are residents. They move up and down with the seasons. Yes, some will blow in from other locations, but you're actually managing your population of spider mites as well as you're managing your crop. So this is something to remember. So when it comes to doing this, you know, the grower needs to think about all these tools. These tools, these acaricides are very important, and they certainly have their place. But there is a little problem. What happens if a grower uses these things repetitiously or over and over again, not thinking of resistance management? Well, then, if that's the case, then certainly you make the beast. So you have to make your decision here. So I think that you can see that you've got great tools to use. You know how to use them. And you can also rely on that bank of predatory mites and other beneficials in your field by making the right decisions. So thank you very much.
Any questions for Bev?
Or even granular to the mix, that does that kind of heat it up for them? They're going to end up making a better kill, especially for cleanup sprays.
Gosh, I don't know that. I've never tested that, Daryl. Can't tell you.
Hi, Bev.
Hi, Tracy.
So do you think bifenthrin ever worked on mites?
You know, that's a good question. Although it's interesting that it's labeled as a miticide, but I think that most growers don't really think of it that way, nor do they use it that way. But for us, it was just simply one of the ones that we could use that was an industry standard to kind of give a comparison as to what was going on. Frankly, nobody I know uses bifenthrin as a miticide.
We've actually seen over in Yakima where it increases the fecundity of the mites using bifenthrin. In fact, like Alan Schreiber was saying, he actually sprays his field with Danitol 3 times to flare mites.
Certainly, your pyrethroids can do that.
Yeah. My question for you, Bev, when you're making your solutions, do you buffer your water?
In this study, I don't believe we buffered the water in this one. We don't buffer it in our decline study as well, because if we start buffering things, then it becomes a quagmire. Yeah.
Anyone else? Yeah. Is there a hand over there? Yeah. Okay. Thanks again, Bev. Pesticide credits over on the tables. And thanks everyone for sticking around today. Please leave reviews for the speakers. And for those that are going to come tomorrow, we'll see you tomorrow morning.